All right, ladies and gentlemen, this session is Google Cloud FHIR APIs and Data Harmonization with Marianne Slight, Kalyan Pamarthy, and Vivian Neely of Google, moderated by Omar Shaker. Go ahead.
Thank you. Hi, everyone. Welcome. Thanks for joining us. We're extremely excited to have you all here. This is the session on the Google Cloud FHIR APIs and our Data Harmonization Suite. My name is Kalyan Pamarthy, and I'm the product manager on FHIR and HL7 in the Google Cloud Healthcare team. Joining me today are two of my colleagues, Marianne Slight, who's the product manager of Healthcare Analytics, and Vivian Neely, who's a solutions engineer on the Healthcare Life Sciences team. Next slide, please. So today we're going to cover three main topics. I'll be spending the first 5 to 7 minutes giving a quick overview of the Google Cloud Healthcare APIs and focusing on our FHIR capabilities. I have one slide on instructions on an upcoming Let's Build session where you can experience in live all the various FHIR capabilities that we have. And then I'm going to hand it over to Marianne and Vivian to talk about the Healthcare Data Harmonization Suite, as well as the demo of our data harmonization capabilities in the Google FHIR server. Next slide, please. Before we jump in, I wanted to call all of your attention to a few other sessions that are happening at DevDays that might be interesting and related to the Cloud Healthcare APIs. We have a follow-up to this session, which is a Let's Build on Google Cloud FHIR APIs. It's coming up on Thursday, June 18th. We'll have some instructions for you all as part of this presentation. We have two community tracks, one on building machine learning systems on FHIR with BigQuery and Looker. Adrish Sannyasi from our solutions team will be covering that topic on at 4:15 to 4:30 today. We have a session on extending clinical workflows using Smart on FHIR. Dharmesh Patel will be covering that from our solutions team. We have two partner sessions showcasing applications that have been built in the Google FHIR APIs. One about cancer referrals from the University Health Network. Tirth Patel will be talking about it on Tuesday. David Burdick from Stratus will be talking about building real-time machine learning systems on the Google Cloud Healthcare APIs as well. So don't miss any of these. So let's dive into the Google Cloud Healthcare API. Next slide, please. So at a very high level, the Google Cloud Healthcare API is our primary API service for managing healthcare-specific data in the Google Cloud Platform. Our goal with the Cloud Healthcare API is to accelerate solution development. And we do this through healthcare data interoperability, helping developers build machine learning and AI solutions, as well as applications that require data access. So the Cloud Healthcare API has fully managed standard-based APIs for a variety of different data standards, data formats, FHIR being one of them. We support DSTU2, STU3, and R4. We also have support for HL7v2 and DICOM. In addition to supporting data standards, we offer a suite of value-added capabilities such as de-identification on FHIR and DICOM, data harmonization, which Marianne and Vivian will be walking us through in this session, natural language processing, and others. The Cloud Healthcare API is built on the Google Cloud, so it comes with our compliance for regulations such as HIPAA, HITRUST, etc. We're also tightly integrated with other Google Cloud applications, for example, BigQuery, to do analytics on FHIR data, as well as other cloud components such as Cloud PubSub for notifications and Cloud Functions for developing other downstream applications. We also support Smart on FHIR applications in collaboration with our Apache API Management Suite, and our session on Smart on FHIR later in the week will cover some of that. So digging specifically into FHIR, here's a quick overview of some of our FHIR capabilities. There's a lot more information on our website, but just to call out a few, this is, again, as a reminder, this is a fully managed service. We support DSTU2, STU3, and R4. We support all the basic operations for CRUD, history, delete, etc. We also support FHIR search, patient everything, execute bundle. And we also support profile validation, which, as we all know, is a crucial component of the compliance with CMS ONC regulations. In addition to the FHIR operations, we also support a number of different methods to bring data into the FHIR store, the FHIR service, as well as from the FHIR service to other applications. For example, HL7B2 and CSV to FHIR transformations, import and export of the data from Google Cloud Storage, which is typically a staging area before data is brought into the FHIR server, and exporting FHIR data to BigQuery both in streaming and batch for large-scale analytics and machine learning. Next slide, please. So to give you all a quick overview of how simple it is to use our managed FHIR services, here's a few examples, right? And so the organization of data within Google Cloud is as shown in the diagram on the top, right? So we've got a Google Cloud Healthcare API. It can be we could configure a specific location where we want the service to run. And within each location, we have the concept of a data set. So a data set is a container for a number of different FHIR stores. The data store that has the FHIR data, it's called the FHIR data store. And you can have a number of different data stores within a data set. Our customers typically use a combination of either one monolithic data store or separate their data into multiple different data stores based on the use case. At the bottom of the screen, I have a quick example of how we would query the FHIR Cloud FHIR store. For example, a simple example is getting patient data. So you'll notice that we've got the base URL, which is healthcare.googleapis.com, our version, the project information, location where we're running the service, the dataset ID, and the FHIR store, right? And after that, you'll see the /patient/1 is the standard FHIR operation for getting patient ID 1. So this is just a quick example. We're going to show a lot more information about how to access data from the FHIR server in our Let's Build session that's coming up on Thursday. Next slide, please. So just to give you all a sense of some popular use cases that customers are deploying the Google FHIR APIs in. So we see three common patterns. The first one is cloud-native health applications. And these applications are using our FHIR server and APIs as the managed backend for consumer enterprise applications. Examples of these could be companies trying to build diabetes management applications or practice management systems, where the managed FHIR service is their primary data backend. Another common pattern is what we're seeing, particularly in the provider space, where providers are creating a secondary data source, secondary clinical data repository based on FHIR, right? And in this case, the FHIR server is interacting with the other systems at the provider, primarily EMRs, lab management systems, archival systems, et cetera, and bringing data out of it and converting it into FHIR, and then using the FHIR service to run their real-time applications and large-scale data analytics. The third use case we're seeing, of course, this is something we're talking a lot about this week, is implementing payer data access APIs on the FHIR server and implementing smart on FHIR apps. Again, we'll go through a lot of this in our Let's Build session that's coming up. So the Cloud Healthcare API is generally available. There's a lot of information online at cloud.google.com/healthcare. I'd encourage everyone to stop by, take a look. We have a lot of code samples, examples on how to get started, et cetera, on our website. So in terms of instructions for what's coming up, we have our Let's Build on Thursday. So please stop by and experience the full power of the Cloud Healthcare APIs. In order to get access, we've set up an environment to configure various users. So the way you can get access is go to this link, bit.ly/GCP/FHIR, and fill out a quick form. And at the end of each day, we're going to look at all the submissions in the form, set up the accounts, and send users a quick email with instructions on how to access the Let's Build. In that email, you will get a list of instructions as well as a link on where the lab is set up. Feel free to take a look at the lab before Thursday. try to play around with our FHIR server, and then bring your questions to our lab on Thursday, where Vivian and myself will be walking through the tutorial as well. Next slide, please. Okay, so that's a quick overview of the FHIR API. Marianne, I'm going to hand it back to you.
Thank you very much, Kalyan. So what I want to do is talk a bit about data harmonization and how you can get your data into FHIR. So typically when we look at clinical sources, there's a couple of different dimensions we need to think about. One is the historical data versus any incremental data or streaming data. Another is it's very common that we see multiple EHR instances that are configured differently from each other, or one health system having multiple EHR vendors for their different facilities. And unfortunately, it's not uncommon that these don't share data dictionaries. And so there's a whole boatload of data harmonization that needs to take place in order to end up with a single real-time secondary data layer on FHIR. The formats that these data come through are often different, and the way that we think about data harmonization is as FHIR as a key target schema, but we also enable data harmonization to other schemas as well. And the types of transformation that we think about are in these four categories. Field mappings, so perhaps I have a field in one system that is patient.id, another system it's MRN, and in another system it's member_ID, and I'm trying to align it into the patient ID resource in FHIR. Often my different EHR systems or other clinical ancillary systems are capturing discrete data, but in different terminologies. So for example, perhaps in one system, my medications are being captured in FDB, in First Data Bank, but then I have a Cerner system where my medications are captured in Multum, and I'm trying to harmonize those all into RX norms, say. Units alignment, because it's not uncommon that different labs produce lab test results with different units, most often different by a factor of 1,000 or so, but sometimes there's a point in time where the standard unit of measure for a particular lab test changes, and so you need to be able to harmonize the units for that lab test across time. And finally, clinical entity extraction, because so often there's a depth of information that's buried deep in the physician's unstructured clinical note, and enriching the structured data, enriching your FHIR store with that data that's abstracted from that clinical note can really add a lot of value. And so the approach that we take is twofold. The first is around mapping, where we are introducing a WSDL data transformation language that takes JSON as an input. You can run a WSDL mapping config against it and gets JSON as an output. Now, the first question that I hear you ask is, wait a minute, don't we have the FHIR mapping language? We do, and WSDL is not the FHIR mapping language. So WSDL is designed for a slightly broader use case than the FHIR mapping language because we need to support all these other schemas as well as FHIR. But it also has a much more compact syntax, which makes it easier to, or easy to use. There aren't any forced profile checks, and we are working on a transpiler for FHIR mapping language as well. So here's an example where I'm taking a JSON of the address of Massachusetts General Hospital, my local hospital, and transforming that through into using a WSDL mapping config. And a couple of things about this. So you can see that it supports repeated and nested structures, as we need with FHIR and with HL7. It also has functions to call and invoke for terminology mapping, unit harmonization, clinical entity extraction, and you can create user-defined functions there as well. And probably most importantly, we will be publishing sample maps for this for HL7 version 2 to FHIR, for FHIR to OMOP, and for OMOP to FHIR. And this WSDL data transformation language is something that we'll be open sourcing in the next couple of months with these sample maps. So how do you run the WSDL mapping config? Three options. The first option is within the healthcare API. So Kalyan talked about the FHIR import API, export API, and so on. And as part of going from cloud storage into a FHIR store, you can insert a WSDL mapping config. The same thing as you're going from the FHIR store through to BigQuery, you can again insert a WSDL config to convert it. And HL7 version 2 store to the FHIR store on Google Cloud, again, insert a WSDL config there as well. So that's your first option. The second option for running the mapping config is through our managed ETL and ELT product, Cloud Data Fusion, which is a fully managed data integration service and has a very graphical UI and a large library of different connectors and transformations so that you can create these pipelines in a much more drag and drop manner. The third way is through an open source data flow pipeline or Apache Beam pipeline, and we're going to be launching a reference, open sourcing a reference pipeline on data flow, again within the next month or two. So that's all well and good, I hear you say, but show me, let me see what this looks like. And with that, I'm going to hand it over to Vivian, who is going to walk you through a demo.
Awesome, thank you, Marianne. Yes, I want to pause real quick and just make sure there's no outstanding questions before I launch into the demo. If the queue is clear, I'll go ahead and start the demo. Okay, awesome. So I'm going to start with the HL7 side of this. I'm going to be walking through how we take an HL7 message and bring it all the way through to FHIR and beyond that into our SQL database. And to start, for those who are not aware, Google has open sourced something called Simulated Hospital. Now, Simulated Hospital is essentially an application that will send HL7 messages. So users can do testing, application testing. We do a lot of our mapping testing. It's a great way for users to be able to test pipelines like this HL7 to FHIR pipeline, utilizing simulated HL7 messages, and you can change the flow of messages. So right now I have 5 per hour. I'm actually going to change this to be about 250, 300 for the demo purposes. So now what's happening is I'm sending about 250 pathways per hour. And so we go over to the pipeline that is running this mapping. It's currently running. You can see here. I started it last night. This is the overall data fusion product that Marianne was talking about as a way to start to run the pipeline of the HL7 to FHIR mapping. So if I refresh this really quick, we can see that there's been 448 messages since I had it at a really low throughput this morning, and that's already gone up. So we can see it kind of walk through the pipeline as we talk. So we can see it starting from the HL7 store. Again, that simulated hospital is sending messages to our HL7 API. And then there's doing 2 things. It's splitting it based on if it's normal or a late message. And these are really just where the mapping occurs. So if I take the properties here, you can see it is pulling the configuration for the mappings from a Google Cloud storage bucket. And it's really this that is doing the brunt of the work, where users can set their configuration, where they can define some functions. And I will be walking through what that file looks like in a little bit. So this also allows you to go through things like metrics to see how fast your pipeline is running, how many errors it's pulling, hopefully if it loads. And so, the Data Fusion provides this beautiful UI so that users who are more familiar with a product like Informatica are comfortable running these pipelines. We can see here what our process time is. So we're averaging around a message per second. Again, that's likely because I had it at a pretty slow rate. We've seen in some of our other customer use cases, we see a pretty strong millisecond time to get these messages through. So finally, we're dropping them into the FHIR store, and this is essentially what it's asking for when building these pipelines. It's just, again, your dataset ID, your FHIR store ID, those properties that Kalyan walked you through earlier in the presentation are essentially what is required in order to set up the FHIR store to receive these messages once they're mapped. This FHIR store is enabled to have streaming. And so what that means is, these 958 messages that I've been sending, or 960 now, are essentially getting immediately dropped into BigQuery. So when you build a FHIR store on Google Cloud, you can enable it to have real-time streaming into our SQL database. This shows up in a data set. You are not required, users do not have to configure the tables nor the schema. So when you enable this streaming export, or even if you do bulk export, users do not configure their tables and the schema, which makes it a lot easier for users to leverage BigQuery to do a lot of their analytics, since they aren't writing long DDLs or building any of the schema and table set. There's also an ability to preview. So without ever spending any money, you actually can look at the data without having to query it. So this is a free capability that allows you to kind of see your FHIR data as it comes through. Now I'm going to be doing a count distinct of observations. So essentially what this is running is how many observations do I currently have in my data set, just to kind of show the streaming functionality of the pipeline. So I'm going to let it run in the background while I walk through some of the data mapping, and we can come back to this query and see, kind of watch it jump up as we go. So this is a Jupyter notebook that we have created to help facilitate the ease of mapping. And really what is happening right now is I have a sample message that I'm going to be demonstrating mapping to FHIR. And so this sample message is an ADT01, and really what we're going to be doing is when it gets sent into the HL7 store, it gets sent through our HL7 parser. And what this does is this takes the text file of HL7 and converts it into a JSON. So we can see here, this is really what it is converting to, is once it has the parsing logic, it turns it into these, all of the headers and segments essentially become numbered. And so we can see here on the third segment, first spot, we have Cerner, and that does equate to, right here, we can see from the, on the third segment of the MSH header, we do have the Cerner logic that it's being sent from that particular EHR. And this parsing logic is what allows us to have the JSON functionality or the JSON format that allows us to then map to FHIR. So we'll load the WSTL specific extensions. Again, WSTL is the language that we are using, or that we created to basically help us and facilitate that mapping process. So this downloads the doc string. Great. And so the first thing that I do is really just demonstrate a simple mapping to a top level field. So right now I'm doing a mapping to bar. I could change this to foo and run it, and you can see it's live editing this. So what this allows us to do is it allows us to change the mapping on a real-time basis. That's changing that Google Cloud Storage bucket with the configurations that we are choosing to demonstrate. So that's a bit easy. I'll get a little bit more complicated where I'm doing a full ADT01 to FHIR. And so really what this is showing is the process. We have a defined function for ADT01. You can see it's doing even a function for MSH. It has some of the out resources. And really what this equates to are two things. We have the messages function, functions defined, which are in the messages whistle file. So you can see here some of the function definitions and resources that are being called from that, as well as the segments. So again, that MSH header has a whole function defined around how we are handling specific headers and segments. Again, so this is allowing you to do things like we could comment out this segment and it will add, oops, a top level, oh, I guess, ignore it. Okay, and so what this essentially is showing is that we are calling a bundle, a transactional bundle, to send this ADT message as a FHIR resource, a transactional bundle. And so we can search on this, and I'm actually going to pull it up in a new view so that folks can see better. So we can search resource, and it will show all of the resource types that are coming out of the ADT 01. So organization, we have a couple organizations. There is a, let's see, a device resource, a provenance resource. This kind of searching ability allows you to see which resources are being published to your FHIR store from that particular HL7 message. You can also search for method, and it will show you which methods are being used for each of these resources. So we're putting into the FHIR store. And so if we go back to the BigQuery, we can see we're at 18,000 observations. I'm going to run this again to just demonstrate. So it went up about 100 observations in that quick 5-minute demo or so. And this really allows you to see the streaming capabilities behind and truly the scaling capabilities behind BigQuery. So this is a no operations model in that you're not managing the backend infrastructure. I can keep adding FHIR resources to this, and you will never have to expand that infrastructure or add, worry about any of the backend run behind this SQL database. So real quick, I'll show a little bit about some of the data that's currently in BigQuery. So I'm going to select patients and show a little bit about how the patient resource looks within BigQuery and how users can query this as they go. And I have, you have the ability to add cached results. I currently do not have that selected, so I could demonstrate the observation. But here we can see the patient ID, the family, birthdays. This is just some, I selected very distinct patient information or patient columns based off of what might be populated with the data set. We can also demonstrate some of the nested functionality. So I'm taking away the select distinct, and you can see the arrays. So for example, given name is an array here. And so that will be added, address is an array. Those particular fields do show up within BigQuery as well. So you do have the structure of FHIR and the integrity of that structure does remain intact when utilizing BigQuery. So I'm going to navigate back here. I'm going to share this slide. Next Thursday, we are having a Let's Build event that's going to walk through really building a FHIR store, enabling that real-time export or that streaming export to BigQuery, showing you the BigQueries, as well as playing around with a little bit of the sending resources to it. So for those who are interested in joining me on Thursday, this is the link to be able to access that. Access will be granted every night and on an ongoing basis on Thursday. So that is all for our particular presentation. I will give the floor back to our moderator to let us know if there's any questions, or folks feel free to comment on the meeting invite or the Zoom invite.
Hey, Vivian, this is Kalyan. I just wanted to call out one other slide before we went into questions. You can take us to slide 18, please. Awesome. I just figured we had a few minutes left. So I wanted to bring everything that myself, Marianne, and Vivian have been talking about for the past half hour in the form of a high-level architecture diagram of how does all of this fit together, right? So I talked about the various FHIR APIs being able to store data in FHIR format, being able to query it, being able to search and import and export. Marianne talked about being able to transform the data from HL7 to FHIR, and we saw a demo from Vivian about how that actually works all the way from HL7 through FHIR into BigQuery. So I wanted to put this up here as an architecture that brings all of this together. This is a very common architecture for our large customers. And just to orient all of you to this slide, going from left to right, the boxes in purple are the many external systems that live either in the cloud or typically on-prem. Or these could be EHRs, rev cycle systems, imaging or PAC systems, HL7 V2 archives. And as we move to the right, the boxes in blue are the various capabilities in the Google Cloud Healthcare API. And the boxes in green are either custom logic from our customers or applications that our customers are building on the Google Cloud Healthcare API. So you'll see from the left to right, data is coming in from these external systems, going through either transformation systems such as interface engines or claims clearinghouses, but also in many cases going through the transformation pipelines that Marianne and Vivian just talked about, right? So if you follow the HL7 to FHIR arrows at the top half, these use the pipelines that we just described, right? And so this is where the data harmonization capabilities sit in the architecture. As we move to the right, there's also opportunities for customers to write business logic, for example, deduplications, being able to tap into an EMPI, for example, in addition to the harmonization capabilities. But once the data is in our FHIR store, now it drives a variety of different applications and value-added services, right? So you'll see I talked about DID very briefly, but that is the capability for us to de-identify certain elements of FHIR and DICOM. With our FHIR APIs being able to access resources, search, run operations, now we enable a whole set of different applications to the right in terms of, it could be CMS, ONC based applications. It could be running machine learning models, bringing the data back into the FHIR store or driving other downstream systems. Or as Vivian showed, exporting the data into BigQuery for large-scale analytics. So you'll see many of these, each of these arrows and combination of arrows from left to right is a real-world use case where the Google Cloud Healthcare APIs and the data harmonization suite is being used. The other sessions that are coming up over the course of this week about Smart on FHIR, BigQuery, you'll see some of these use cases play out. So with that, we can go back to slide 19. And we'll leave this up here and see if there's any questions.
We appreciated the flow of it, taking us from the big picture to the actual flow diagram shown by Marianne, and then finally the demo really brings it home. That certainly inspired me, and I'm wondering about a lot of things. We do have one question from Dav, and he's asking about patient matching. How does patient matching happen during translation and also before storing in the FHIR server?
Yeah, so this is Marianne. So we don't offer a master patient index, but master patient indexes that run on cloud can run on GCP. So if you have one within your own health system that runs on cloud, then you can run that on GCP. We also, though, recognize that quite often people have systems that are sort of related, but not quite identical, and in that case sometimes they have similar patient identifiers, but they're changed by a digit or have an extra character or so on added on, and that's a case where using the user-defined functions within the mapping whistle is very helpful.
Awesome, thank you so much, Marianne. We do have a few questions coming in, and I just want to remind everyone to use the Q&A button rather than the chat, so that we can see your questions. Also, check the questions and upvote any that you might have, so that you can help me prioritize them. All right, so we have another one coming up, and feel free to just volunteer to answer. We have three speakers here. I want to make sure you guys get some chances. So the next question is your mapping from A1 to FHIR based on HL7 version 2 FHIR mapping spreadsheets done by V2 to FHIR to the FHIR project, which I believe is an open source resource out there.
Yep. This is Vivian, and Marianne can also answer. So all of the mappings that we are going to be, the mapping examples that we are going to be open sourcing using that whistle language and mapping engine are based off of the HL7 to FHIR community sheets. We constantly contribute to those, as well as we take the updates from all of those sheets and implement them in our open source or soon to be open sourced version of this. And so they are directly pulled from the community mappings of HL7 to FHIR.
Awesome, that's good to know. And Vivian, while I have you, we have another related question about whether or not you guys tried to apply whistle to X12 to FHIR mapping.
Yes, Kalyan actually might be able to answer that a little bit better. We have actual implementations with a little bit of X12. We've done this with CDISC data. Again, Marianne mentioned OMOP data. The concept and the reason we developed Whistle was truly so that we could take arbitrary JSON to arbitrary JSON, and that is why, and the power of Whistle is it does allow you flexibility for different outputs and inputs like X12 to be utilized.
Awesome, thank you. We got a few more questions. The next one is about whether Google Cloud supports the US core.
Actually, I'm sorry, I'm going to interrupt here. We're at our time limit. So if we can, the speakers can, all of the questions that are out there right now, you can answer via the chat room, and it will be available all day and throughout the rest of the meeting.
Great.
Fantastic.
We will follow up on any questions.
Fantastic. Thank you guys so much, and enjoy your next session.
Thank you.